Today we will be discussing molten salt energy storage and the pursuit for clean, efficient energy storage. First of all, what is molten salt? Generally, the molten salt used in plants is a combination of sodium and potassium nitrate, materials that are readily available for use. It becomes molten when heated up or compressed at high pressure. The low vapor pressure and relatively high thermal stability of molten salt makes it an ideal heat storage medium. Now, how do we utilize this salt to store energy? In a general sense, energy is stored as heat in the salt with the use of solar mirrors. When needed, the heat is used to generate steam, which in turn powers a steam turbine that produces electricity. Let's break down this process even further. First, light is concentrated to a tower where the salt is stored. Using sunlight as the primary energy source makes this process entirely renewable, while mitigating the issues with traditional solar energy PV panels by allowing for longer-term storage. Once the salt has become molten, it is transported to an insulated storage tank. The storage tank holds the salt until it's ready for use. When electricity is needed, the heat from the molten salt is used to generate steam to power a traditional steam-powered turbine. The salt is then deposited back into the cold storage tank to be heated again. The process is highly efficient due to its circular nature and the ability of the salt to really capture and hold on to the thermal energy. What are the engineering solutions this process brings about? Once again, it is an efficient, renewable design and generates little to no emissions. Additionally, the molten salt is non-toxic, so if there were to be a leak, there is no serious threat involved. Most importantly, it's beneficial because it can be stored for later use. Because of this, the energy created from the molten salts can be used to supplement high energy demand peaks. Lastly, it's becoming cheaper to produce. In 2009, a plant that had a 110 megawatt capacity produced energy that cost 13.5 cents per kilowatt hour. Even better, in 2017, plants have started to produce energy that costs less than 5 cents per kilowatt hour, mostly due to more efficient systems. Of course, there are still improvements to be made to make this system even more desirable. Expensive materials and maintenance must be used to keep the salt from corroding the storage tanks. With proper maintenance, though, these facilities can last for quite a few years. And some energy is lost to keep the salt from freezing when not in use. In terms of the triple bottom line, where does molten salt thermal energy stand? Environmentally, there are no emissions, the molten salts are reusable, and there is relatively no waste. Economically, it is feasible because it is a much cheaper option than other energy storage plans. In particular, it was recently estimated to be about 10 times cheaper than battery storage. Upfront costs will be high, but the overall lower costs and high efficiency make it worthwhile. In a social aspect, the generation of molten salt thermal power will help generate jobs, stimulate the economy, and protect people from harm that would otherwise be a threat from toxic materials. Overall, molten salt thermal energy storage is a viable and greatly beneficial green engineering solution. Finally, some interesting statistics about this process. The salt used does not need replacing for the entire 30-plus year life of the plant. Molten salt technology represents 3/4 of the thermal energy storage worldwide. One plant in Nevada generated enough energy to power 75,000 homes. That's nearly 10% of the owner-occupied homes in Nevada. As this technology advances, even more homes may be powered.